In this problem, we're going to prove that this sum is equal to all of this stuff over here. So let's go ahead and go through it very carefully. So proof. So we'll start by just basically writing down the left-hand side and then just expanding it and seeing what happens. So we have the infinite sum as I runs from 1 to capital N of all of this stuff here. So I'll write it again, AXI plus BYI minus CZI. I'm writing a little bit small because it's going to be very difficult to fit this in here. I think maybe what I'll do is come down here to this next line and then just write it all out. So we'll start by plugging in 1. So you plug in 1, and so you get AX1 plus BY1 minus CZ1, or Z sub 1, plus, right, it's a summation, so you add the next one. So now you plug in 2, so it'll be AX2 plus BY2 minus CZ2, and plus, etc. You just keep plugging them in and adding, and the very last one that you plug in is capital N. So the very last term will be AX sub N, whoops, it's a capital N, plus BYN minus CZN, just like that. Okay. And so now we have to figure out how to get this. Basically, we have to get A times the sum of the x's plus B times the sum of the y's minus C times the sum of the z's. The natural thing to do is to group all of the x's, the y's, and the z's. So let's carefully do that. So here we have AX1, AX2, AXN. So we're going to group all of those together using the fact that, addition is associative, so we could do that. So this is parentheses AX1 plus BX2, whoops, plus AX2 plus ... plus AXN, right? And we're allowed to do that again because addition is associative. So plus, now we'll do the B's. So B, B, B. So we have BY1 plus BY2 plus ... plus BYN, right? Really nice. So we started by looking again at just the A's. So A, that's these here. Then we did the B's, 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 that's this here. And now we're left with the C's. So they're all being subtracted. So what we can do is we can pull out that minus sign from all of them and write it like this, minus, and then we have CZ1, that's this one here, and then plus CZ2. Again, we pulled out that minus, right? So it's gone. Plus ... plus, and then the last one, CZN. So it takes some getting used to. This is a nice practice problem if you're going to be doing, maybe some stuff with sums, and some statistics stuff. You see a lot of stuff like this. Okay, what can we do here? Well, here now what we can do maybe is pull out these constants, right? So we can have A, x1 plus x2 plus ... plus x sub n. Same thing here, we can pull out the B, so B, then we have y1 plus y2 plus ... plus y sub capital N. And then same thing here, we can pull out the C, so minus C, and then we have Z1 plus Z2 plus ... plus Z capital N. That should be a capital N there. I messed up there. There we go, easy to fix. All right, and then now we just write these, in summation notation, right? So A, this is the sum of the x's, so this is the sum as I runs from 1 to capital N of x sub I, and then plus B, and then we have the sum as I runs from 1 to capital N of B of y sub I, and then minus C, then we have the sum as I runs from 1 to capital N of z sub I. And that completes the proof, right? That was, let's go back and check. That's what we had to show, right? Let's see. Yep, that's pretty much it. So not really a tough problem, just a good exercise in like getting used to, just working with the sums. So again, you start by writing out, the terms, and then just group together the x's, group together the y's, group together the z's, factor out the constants, and then just go back to summation notation. So I hope this video has been helpful in some way. Good luck.